MTU stands for Maximum Transmission Unit, which is a parameter that determines the maximum size of a data packet that can be transmitted over a network. It represents the largest amount of data that can be encapsulated in a single network packet without being fragmented. The MTU size is typically measured in bytes and varies depending on the underlying network technology and the protocols being used. It is an important consideration in network communications as it affects the efficiency and performance of data transmission. Here are some key points to understand about MTU. Fragmentation. When the size of the data to be transmitted exceeds the MTU of a network, the data needs to be divided into smaller packets known as fragments. Fragmentation adds overhead and can impact network performance. It is generally preferred to keep the packet size smaller than the MTU to avoid fragmentation. Network efficiency. A larger MTU allows for more data to be transmitted in a single packet, reducing the overhead associated with packet headers and improving network efficiency. However, a larger MTU also increases the risk of fragmentation if the network path cannot accommodate the larger packet size. Path MTU discovery. Path MTU discovery, PMTUD, is a technique used to determine the maximum MTU size along a network path. It helps ensure that packets do not get fragmented and allows for optimal data transmission. PMTUD involves sending packets with increasingly larger MTU sizes and adjusting the size based on the responses received. This process helps determine the maximum MTU size that can be used without fragmentation. MTU and different network technologies. Different network technologies have different default MTU sizes. For example, Ethernet commonly uses an MTU of 1500 bytes, while some point-to-point protocol, PPP, connections may have an MTU of 576 bytes. Internet Protocol version 6, IPv6, has a larger default MTU of 1280 bytes to accommodate the larger IPv6 headers. MTU tuning. In certain cases, it may be necessary to adjust the MTU size to optimize a network performance. This is particularly relevant in scenarios such as virtual private networks, VPNs, or situations where network conditions are less than ideal. MTU tuning involves modifying the MTU size to find the optimal balance between efficiency and avoiding fragmentation. Considerations for security devices. In some cases, security devices such as firewalls or virtual private network, VPN, gateways may perform packet inspection and modification. These devices may enforce a lower MTU size to accommodate their processing requirements, which can impact overall network performance. In summary, the MTU is a crucial parameter that determines the maximum size of data packets transmitted over a network. It impacts network efficiency, fragmentation, and overall performance. Understanding and optimizing the MTU size is important for ensuring efficient and reliable data transmission in different network environments.